Good morning, everyone. Thanks for joining us at this Agentic AI Summit. This is the frontier stage, so I'm going to present a very new project, new open source project that's pushing the boundaries of the collaborative AI. How new is this project? It's just 7 days old. The first MVP was just out 1 week ago. So good luck with me. I've never presented a project as young as this one. In one word, this is a multi-agent scaling system that runs multiple agents, diverse agents, in parallel, sharing intelligence and refining each other's work. Okay, and you can check the GitHub from MassGen.ai link. And yeah, let's dive in. So if you have followed the recent breakthroughs from Grok Heavy or Gemini DeepThink, it's easy to see the inspiration. Harnessing multiple AI minds that tackle complexity far beyond any single model can do. Okay, there's a lot of recent exciting things about it, and the North Star is that we want to build co-evolving agents through collaborative interaction. So many of you have probably know that I've created this MassGen open source framework since 2023. I've been working on idea and now AG2 for these multi-agent conversations. But many challenges still remain, and especially with the change of the new technology. In April this year, I wrote a blog post called Myth of Reasoning, and I talk about this thread of thoughts idea. And the key insight is that the human reasoning is actually much messier than what most people realize. So most time we have intuitive thoughts, and only after that we try to find justifications or find it's wrong and restart this process again. And but we need to make it cleaner for presentation, for communication, to convince others. So the nice chain of thought is not a start. It's the outcome of these massive processes, and by nature it's collaborative. Right? So that's kind of one of the key insights I've been working on in the past few months. And recently I've seen real evidence in practice. So Grok Heavy and DeepThink, they prove that this is not just theoretical, it's practical and deployable. Right? Let's take the Grok Heavy as an example. If you check their performance on last human exam, right? Very, very challenging benchmark. Grok 4 standard achieves about 38%, and Grok Heavy achieves about 15% higher. By doing what? The same model. They run the same model, but just using multi-agent architecture. And they price it 10 times higher, right? $30 versus $300 per month. So that's basically the price just for this multi-agent architecture, nothing else. And by the way, DeepThink, Gemini DeepThink is also available now in Google Ultra, also in the highest tier subscription. So I think these are like the most strongest commercial evidence I've seen so far about the power of multi-agent architecture. But what if you don't have access to those expensive subscriptions? I have the good news for you. Okay, just if you use MassGen, you can just use any existing API keys you have to any models. You can easily kind of run this experiment of multi-agent scaling, right? You can use a single model with different configurations or mix multiple different models or agents, right, as you want. And how this works is this MassGen orchestrator will take a user's query, distribute that task to the multiple agents, and run them in parallel. And the magic happens when there's this shared collaboration hub, right? So all the agents, they can check the real-time updates from others, criticize and refine the results, right? And if some agent finish the work but other agents have new updates, then the agent might get restarted. And eventually they will converge to some consensus and generate a final answer. So that helps refine the quality. And here we can see that the multiple ideas are integrated together. We want to kind of leverage the strengths, unique strengths for different models of different providers and different agents. And we want to run them in parallel to slash the latency. But in the same time, we want the agent to be able to absorb and take intelligence shared from others and improve their own work. Okay? And this iterative refinement keeps going until the consensus. It's very easy to get started. You can simply clone this repo and install some minimal dependencies and get your API keys configured. Okay? And then you can use the CLI to run some configurations. You can configure them differently and try them out. You can either use interactive mode to have multiple turns conversations, or just ask simple questions. Let's do a quick demo here. So I already have VS Code open and already cloned the repo. So I'm going to try to run the latest version. If you are using the main branch, you may get a slightly different result. Here I'm using a 3-agent default configuration and asking, give me all the talks on agent frameworks in Berkeley Agent AI Summit 2025. Okay, let's run that. Okay, here the system gets started. You can see the question on top and the 3 agents running in parallel. The first agent using GPT-4o, second one using 4o mini, and third one using Grok 3 mini. And you can see all the agents are working in parallel. Some of the agents have access to building web search tools or code execution tools, so they will invoke them when they need to. We can see that some agents already finished work, like the 4o mini already provided some answer and have several rounds of voting already. And okay, after the working, we finally selected one agent called the 4o agent. Let's see, and the 4o agent is doing the final presentation to generate final answer. Right? You can see the whole process, and the 4o got 3 votes here by the end of the interactions. We can check the output for each agent. Here I enter 1, so let's check agent 1's working process. So this is a log, right? We see that it started with some web search. After search, it generated the initial answer, like this. It found a few talks, some final discussions, and gave a link to the Berkeley website. And later it has some voting about the agents. Okay. I can also check the second agent, the 4o mini. Yeah, it generates some answers. Says it didn't use web search, so it didn't find the right information. Let's see the Grok 4 mini. Yeah, the initial answer from Grok 4 mini is they don't have access to the information, but later once it sees other agents' answers, it updated the answer. Actually, you can see another answer provided from here, so it's actually updates the answer. But eventually, it's also voted for all. Okay, and the final answer is presented by 4o, and it combines the information from all the different agents. Okay, so that's a simple demo. You can try this out and try different queries. There are a few earlier case studies when we had the first version. So this was using the current main branch. And we tried a number of different examples. For example, we asked agents to find who is IMO 2025 winner, which AI wants IMO 2025. And we can also ask open-ended questions like do some collateral writing, write a story for like robot music stories. And we can also ask very hard questions like how much does it cost to evaluate Grok 4 on the HLE benchmark? This is an open question. You can't find any information online to directly answer these questions. But some agents can find a piece of information from the website, and some other agents can use their code execution, data analysis capability to do the estimate. So eventually, the multiple agents can collaborate to try to answer this question. We can also ask questions like travel guide, like if I want to travel to Stockholm in October, can provide a travel guide. Usually a single agent will find some information, but each of them will find slightly different information, and only when you put them together, you get the best answer. So from this case study, you can see there are several different flavors or reasons why this multi-agent scaling can help. For open-ended questions, usually different agents will have different perspectives, and you really get the best answer from combining them. And for many other hard tasks, it requires many different steps. Usually the initial answer generated by any single agent is preliminary, but after they see others' work, they get inspired and they keep refining their work, and you usually get better answers. You can also understand this from another practical point of view. I don't know how many of you like using multiple AIs at the same time. And when you have a hard question, you try one AI, but you don't really trust the result. So probably you will try another AI and cross-check to make sure you're not fooled, right? So this kind of simulate that automatically, right, by having the multiple agents cross-checking each other's work. But it goes beyond that because it doesn't stop at the first round. It actually try to push them harder, right, to make them further work more, and until they get the final comprehensive answer. So yeah, you can find some of the case studies from the website as well, from the GitHub repo. There's still a lot of, this is very new, right? It's just a start of this direction, and there are a lot of whole set of challenges ahead. The eventual vision we want to have is to have this recursive scaling, so that every time you get a new agent, you add to the system and it amplifies the whole. But we are far from that. So there's a lot of challenges like consensus, shared context, and interoperability, right? We have heard many great talks about addressing these issues. Eventually, we need to solve all these hard problems. But if this really works, then we can have AI that's kind of similar to how we scale ourselves, right? AI can scale themselves too. Yeah, so that's a very brief introduction about this project. This is just the beginning. I hope you can check the repo on GitHub, start it, start discussion, join our Discord channels, and build this together. By the way, the new version I just used it's coming soon, probably this weekend. Yeah, so I will get the chance to try it out and share your feedback. Yeah, thank you very much. I think I still have time for questions.
So any question for Wang's talk? Okay.
Thinking about, it can be customized for me running several coding agents, orchestrating other type of tasks.
Yeah. Great question. Yeah, coding agent is one most important kind of capability I want to integrate into this MassGen. Why is coding a big deal? Because it's a meta power, right? An agent that can change its own software, can self-improve, can experiment, can learn and spawn new sub-agents. And yeah, you have seen the strong, powerful coding assistant like Cloud Code, Gemini Cli integrated into our developer workflows. And yeah, so but right now they are working alone, right? So the single agent working alone. And if we can integrate that into this multi-agent parallel working paradigm, I think the power will be amplified to a large degree. So that's a big next milestone I want to achieve. Great question.
I have a question about if we have, for example, multiple agent booking a ticket,
yeah.
So they try to book it all together. How can we ensure that they don't overbook and double book? Or how can we check that each of our tasks, whether it's failed or not, in a kind of holistic way?
Yeah. This is it touches very important about a conflict, or sometimes the agent's work are not easily kind of scalable, right? That's exactly the kind of the challenges we need to solve, especially when now each agent can have can go beyond question answering. They also have built-in tools that often can do things. So right now, we're not giving the agents that kind of tools. We're only giving them like search, code execution, and they can work in isolation. But as soon as we get to the point where the multi-agent might be working at the same workspace and they have conflict, we have to find a way to resolve that. So that's kind of a great research question to look at next. Yeah. Thank you.
Thank you.
So I have a great talk. So I have one question. So in context learning, we have, let's say, some poor quality examples, it might hinder the whole trajectory. So I want to see, let's say, if we have multiple agents and we are scaling up, and some of the runs are lower quality. So what is your vision how we can make sure that doesn't like hinder the whole trajectory for the agent?
Yeah, exactly. So actually the demo just shows that exactly, right? So 2 agents actually provide very poor answers in the beginning. Only 1 agent find the right answer. And I think this requires some fundamental capabilities to the base models and agents. So each agent has to have a basic way, evaluation capability. So giving multiple answers, it needs to know the relatively better answer for the most of the time. Otherwise, it's not work. I think this built on the assumption that the model has been improving to a point that most of the strongest frontier models have that capabilities. But this is a big assumption that we do need to check. I actually wrote this down in my blog post. I think there are several basic capabilities we need to have. This is one of them. Yeah. Thank you. Thank you very much.
Okay, thanks for Chuan's great talk.